Well, good evening, everybody. Have you had enough snow yet? Yeah, it's been quite a winter. Um, Fortunately, your area is actually weathering this pretty well. So I'm grateful for that. Our watersheds and stuff. I think we will see some additional snow belt. It's supposed to go till 66 or 67 next week, which is for us is wonderful because we need to get into construction and as quickly as we can. So we'll take all the good weather. National Weather Service is forecasting that we will have a drier than normal spring, which again, we're really hopeful. So keep those prayers going that we have a dry spring. So I'm Lucinda Andriani. I serve as Deputy County Manager and Flood Control District Administrator. And tonight we're here to talk through Brandis Way. Some of you may be here that are actually in the Peaceful Way flood corridor because you attended the last one, and we just frankly we're very inclusive. If someone shows up, we keep them on the list. So we're not going to talk about Peaceful this evening. We will be having a corridor meeting for Peaceful once we get these projects well into construction. Then we're going to start turning our attention to Peaceful and to Copeland corridors. So that'll be coming, I'm hopeful, late May, early June for that effort, so to start that effort. And we did just receive the funding for those two corridors. We were able to get the funding for Brandis and Pocky a little more quickly, fortunately, and that's why we're here this evening. We are at 90% engineering, so unlike last time where we kind of went through we had time to go through a more systematic. This time we want to get these measures in place. You're going to see that largely the focus, 99% of the focus is upsizing the channel, and we're staying within that channel footprint. So it's a much easier process than we went through last time in 2012, 2013. Yes, and the engineer will go through with you what the plans are for that. There it is. So I've got a few intro slides that I think open this, or actually we're not going to start there. We're going to start first what I want to do. No, never mind. I'll do it. First, we need to, I want to first introduce Supervisor Lena Fowler is with us this evening. She's sitting in on the meeting. She will be your area supervisor starting in 2025 due to the redistricting, right? Yeah. I thought it's effective. It's effective, yeah. So, well, they approved it, but it actually goes into effect. So, and she'll be here, and if hopefully you all get a chance to meet her after the meeting. I want to turn it over for some brief comments from our Vice Chair and Supervisor Geronimo Vasquez.
Hello, everyone. Good evening. Thank you for being here. It's a great pleasure to be here. It's exciting that we got this funding. I think back about a year ago from now, and it was about the time of the tunnel fire. And so it's amazing that we're actually getting these projects going. So it's exciting to see what's happening, especially with all the lobbying, all the work Lucinda's been doing and her team and all the engineers.
And the board.
And the board. We've been lobbying. We've been out there. I've been to DC 3 times in the last 6 months, out there pushing, and my colleagues as well. And so we got some great results. We have the funding that we need for on-forest measures and the channels. We're still waiting for the transportation piece. That's the area we need. We can use your support. You can email your state legislators and ask them to promote the rural transportation bill that's in there, because there's over $5 million in that bill that would go to Highway 180 and 89. And that's the piece we're missing, are those drainage improvements. We're going to fix things upstream, but if we don't fix those drainage improvements, we will continue to have shutdowns of 89. And so it's really key, and that's a way you can help us. It's not done. When we came and we talked about the $150 million ask that we had, we're at 92 million right now with a little, maybe about 100 of what we need. We still need about $50 million for all the other pieces of the corridors and the transportation piece. So we're not done. It's going to be a long process. These projects we're going to start this year, but some of these are going to be multi-year projects. And so please be patient. Again, we're doing the best we can. We're moving at lightning speed, especially compared to Schultz, and you'll hear a little bit more about that coming up. But we're just really excited to be here tonight and be able to share this with you, and look forward to seeing projects here. And I just heard that Tiffany trucks have been up and down Brandis Way this week, and that makes me so excited because that means we got work going. So thank you, everyone.
Great. Thank you, Vice Chair. So again, I don't need that. I have my mic. Thank you. So this evening, we've got quite a few slides here, although some we're going to go through fairly quickly. Much like we did back in 2012 timeframe, we'll march through this. Just a little bit of history. Some of this I touched on in the meeting that we had last fall, the corridor meeting we had last fall. And I think people remember that the mitigation that's in place now was designed to manage about 400 CFS, cubic feet per second of water. And frankly, I think the only time we saw any kind of real impact to that was the 1,000-year, flooding rainfall event that we had in 2018. Now, importantly, why are we seeing the impacts now? It's because we've seen a 9-fold increase from the 2016 modeling that we did to the flows that are going through that area now. Here's the chart that shows this, that puts this into perspective. And across the entire 9 watersheds, we're seeing anywhere from a 7 to 26 times increase. Little bit, you saw some of this back in the fall. These are the updated figures. We spent over $9 million on response this past summer. So a lot of effort went into. And right now we're sitting at about 275,000 bags in stockpile. My goal is to not spend money producing sandbags this year. My goal is to spend the money on long-term mitigation rather than the short-term. And this shows you the NRCS funding that's now available, that has been approved by Congress. It was approved by Congress 2 days before Christmas in the omnibus bill, and then approved by the president. Unfortunately, it took quite a while for OMB to apportion that money to the Department of Agriculture and into the Emergency Watershed Protection Program, but we were able to secure some other funding for Brandis and Wupaki and start fairly quickly. And that shows you we've got about $2 million in that funding for the Brandis corridor. So, and this shows you the other corridors that were in that application. And we'll be taking to the board, probably not this Tuesday, but 2 Tuesdays from now or 3 Tuesdays from now, Copeland and Peaceful for accepting those funds. And so that's kind of where we stand. And, frankly, I made the decision that even before we got the money that we would move forward with the engineering, because if we didn't start the engineering, there was no way we were going to get into construction this year. Our goal is to construct the Brandis and Wupaki corridors this spring. And that's going to be a Herculean effort, but we got the A-team. Tiffany Construction was selected as the contractor. And if there's anybody that can get it done, it will be Tiffany. So with that, I'm going to go ahead and turn it over to Alan Hayden. You'll remember Alan with Natural Channel Design. They're designing all of the on-forest measures. And so You know that during Schultz, post Schultz, we did a lot of work up on the forest, and we're expanding those watershed restoration measures on forest now through the additional funding. We got additional 42 million. We got 42 million through the U.S. Forest Service disaster relief, and part of that will be to improve the measures that are on forest above the Brandis Way area. So with that, I'll turn it over to Alan to walk through his slides, talk about what we're doing on forest. And this is the game changer, right? These are the really important, it's all important because it has to work as a system, but the work we do on forests is what really has a lot of impact downstream, because if we can't lower the sediment, then nothing we do downstream will work.
You're stealing all my thunder.
Sorry. I'm supporting your thunder.
Thank you. Thanks for coming out tonight. I appreciate it. So I'll start off a little bit about, just what we went through last summer, what you guys all went through last summer, but we were up on the hill kind of watching all that. And Mike Garrison and his crew from Tiffany were also up there repairing things pretty darn fast. But your state of the current watershed is, not great. There's a lot more water coming off of it. With that water comes a lot more ability to do work and carry sediment. And we saw some big incisions, some big deep incisions. Those occurred as head cuts started from outside of our work area that we worked in during Schultz, and cut up into the fan, and then started going up through the fan, working its way through the log sills and stuff like that. Most of that work, most of this stuff got repaired last summer. At the end of the summer, that Tiffany was able to get in there. We were able to repair that. So the fan upstream in the areas that we worked in during Schultz is back to working like a fan. And so it doesn't provide nearly as much sediment as it did during the course of the summer. That said, we have a lot more work to do, but it is piling up sediment, doing what it's supposed to do. It's catching sediment coming off the hill, and it's grading it up onto that fan surface as it was intended. But we do have a bit of work to do, and I'll show you what that looks like. Our major work areas, this is 420 Road here, neighborhoods down here. Here's the lower fan. Here is the upper fan where we saw most of that incision occurring through here. And then we have channels leading down into this, both the south channel that comes into here, into this fan area, as well as this north trib channel. So much of this area was existing after we built it during Schultz, but we are going to be able, during the course of the summer, to expand it and take advantage of a bit more room over here. And they're working on the arc clearances for that this week. And that will help us keep those head cuts from migrating into the fan, because that's where they came from. They started right over in here and then worked their way right up through underneath the power line and kept marching up the fan. And this is what got repaired, but we need to get to the source of it over here. And then a reworking of the terminal trench down here and this lower piece of the fan as it feeds into the engineered channels that go down through the neighborhood, which Rick will talk about in a little bit. But this is up high on the hill, and I think we'll zoom in a little closer. This is what a lot of you guys will see. This is the location of the existing terminal trench, and I think as a lot of you may recall from the last time that, the whole idea of this alluvial fan restoration is to spread the flows out, get them to go slower, get them to have less depth when they flow. And when we do that, then we can reduce the shear stress and reduce its ability to carry sediment. And so that sediment, which is being sourced way up high on the mountains, comes down, passes across these alluvial fans, and we're usually able to arrest 85 to 95% of it. as it goes across the fan. So when the water leaves the fan, it's still spreading out wide, but it's not carrying out nearly as much sediment. So we can hold that sediment back up on the hill, maximize the use of that natural function of the alluvial fan systems that are all around. And then at the end, it would keep going and it would be an alluvial fan all the way out to 180 and beyond, because that's where the neighborhoods are built. What we have to do is kind of truncate that function and turn it into a single channel function, and we do that with this terminal trench right here. We're kind of enlarging the size of it, and we're also putting a bit of a slope on it so that it can keep itself clean as if it ever starts to fill up. Last year, we saw it fill up on several occasions. Tiffany Cruz had to come in, empty that to make sure that it works, because if this fills up, the alluvial fan function keeps going and spreading flows. So a trench goes all the way across, we capture the flow and put it into this channel, this what we call the transition channel, which is a natural channel with rock grade control, and it joins in to the engineered channel here at the Forest Service line. We're pushing about 1,000 to 1,100 CFS is what we're allowed down through here. Overflows go through here and go down onto the lower fan. And then, much as they did during the course of the summer, we take advantage of the kind of cut and berm that was filled in here, and it starts to feed into the channel at this point down here. Excess of more than 300 or so, because we'll have to spread out and keep going where it's gone in the past. And Corey will explain that no adverse impact analysis as we go forward. So, so that's what this looks like. It looks very similar to what is there now. There's a lot more grade control over into this side, a lot more grade control into the channel, and slight enlargement of the channel to match the enlargement of the channels downstream in the neighborhood. So these are what these practices look like. If you were here last summer, you saw a lot of this happening. For grade control, we use these, use native rock, large native rock that's designed not to move during big flows, and it keeps the grade of those channels. It keeps them from sinking and producing sediment, but it also keeps the shear stress off the banks with these wing arms and keeps the flow into the center of the channel and reduces bank erosion. This is what one of those looks like as it's working, okay? On the fans, we have to use buried grade control. It's to keep head cuts from moving back up through the fan, give ourselves a floor to basically keep material stored on. This can be in the form of buried log sills using logs or buried rock sills all the way across the fan. Okay, that holds the fan shape. And then we finish it off with seeding with native vegetation and fan work and smoothing out and all that kind of stuff there. The vegetation is a really important portion of it. We can get grass to grow, we can keep those rills from forming, and it takes a lot of stress off of our grade control features. So I will be in the back and this evening, and we can go over these plans if you want. If you have any questions, happy to answer the questions, but I'm going to turn it over to Rick right now.
Hello, everyone. Rick Schroes with Civil Tech. I'd like to go over the off-forest ideas that are being designed. I'm going to take you back in time, and of course you all remember this, or those of us that were here, and we were. In 2012, the off-forest design considerations that we had were based upon a 5-year, 24-hour design storm after the forest had healed for about 2 years. That yielded about 400 cubic feet per second of flow coming down the channel in Brandis. We did look at no adverse impacts, which means that if we were to construct the channel as we did, that it wouldn't have any adverse impacts on properties down the stream hadn't we built the channel. A lot of things were done, as you know, utility relocations. There was a lot of utility relocations. The channel was constructed, 5 freespan bridges were constructed, turf reinforcement mat type lining was placed on the channel. Articulated block was also placed on the channel, which is that block that kind of looks like a block wall turned on its side. The roadway elevations on Brandis were also modified to make Brandis tilt toward the channel. 2 box culverts were constructed at Brandis near SR 89, and all drainage easements were obtained at that time. This is just a picture showing the TRM channel lining when it was new in 2012, and the articulated block also. The pointer. This is one of the freespan bridges being placed, and the box culverts down there, SR 89, double box, 4x8. So in 2019, there were some modifications done here on the channel after the 2018 large storm event. The 5 driveways, the channel underneath the driveways was reshaped from a trapezoidal, which has side slopes which are tilted and sloped, to more vertical, thus allowing more water to flow underneath the bridges than if it was trapezoidal shape. And there was some shotcrete done, and TRM replacement up on the west end, up west of Ostrich. This kind of shows you the sloping channel here and how it transitions to a more vertical channel. This is the one on Ostrich, same idea. This is just a shot of the channel lining, the shotcrete channel lining, and the TRM again. So 2022, the same thing has happened. There's been a full burn in the watershed. It's about 1,142 acres was burned in pipeline. Except this time we're, instead of the 5-year frequency storm, we're modeling what's called a 2-inch in 45 minutes. Remember, the 5-year was 3 inches in 24 hours. So the modeling that we're doing is much more hefty here. The discharge off the forest is about, for that storm, is about 1,400 cubic feet per second. Before it was 400. We're utilizing the existing channel alignments. Basically, the channel stays the same, except it's being relined with shotcrete everywhere. The easements stay the same, the environmental clearances stay the same that we got during Schultz. So everything, we're trying to stay within that old footprint that was established during Schultz. There was an achievement of a cost-benefit ratio was done and calculated by Lucinda's group in order to get the NRCS funding. And no adverse impacts is also taking place by an independent group, and Corey will talk about that later. So as I said, it's a trapezoidal shotcrete channel. The bottom width varies depending upon how much room we have. There's 4 sections, and I'll just go over them briefly with you. 4 different channel bottom widths. There's going to be an additional box culvert at Brandis. What this will all do for us as a system is it'll increase our flow capacity, allow for easier maintenance and cleaning. The roadway elevations are not going to change, except we probably will have some regrading in there due to what happened at during the last summer events. And also there will be some slight modifications to the paving over the top of the box near SR 89. Existing drainage easements, they're there. We want to keep them. We want to utilize them. So we're not going to acquire any new easements. This is just an illustrated plan showing the channel. You're probably familiar with it. Forest Service boundaries over here, and SR 89 is over here. So basically, at the end of all this construction, you'll see one uniform channel of shotcrete surfacing. And these are just our construction plans, just to show you we're at about 90% on the design. We have some final things to take care of on the design. And just to let you know, we have 2 sets of our 90% plans, one at that table and one at that table. So after this is over, if you'd like to look, see what we're planning on doing, you're welcome to come over and ask questions. These are the channel cross sections I was referring to. If you take a look, really the only thing that changes on each of these cross sections is the bottom width and the side slope. We like to keep the side slope flatter when it's adjacent to the road. In case there's any lane departures of vehicles, we like to have them flatter so you can correct yourself without going down into a ditch. This one is 8 feet wide. By the way, we're going from west to east here. 10 feet, 8 feet, 20 feet, 15 feet. There's the 20, there's the 15. And it's really, these slides didn't turn out exactly how I was hoping, but it kind of, you can't really tell here, but this shows the transitions between the different widths of the channel on these slides. And you'll see them better on the plans if you wish to come over and look at those. This is the east half. That was the west half I just showed you. This is the box culvert we're proposing over near SR 89. The idea is to place an additional box, same size as the other two, to the north of the other two. That provides approximately a 1/3 increase in capacity. Corey is going to talk about the NAI, or no adverse impacts now.
As Rick mentioned, we will have the plans over. Really encourage everybody to go over and look at the plans and see what's specific related to your property. And I know that a specific area, Jonathan's here, and a specific area that I think Rick's really focused in on is the curve and that the drain out there at Monsoon, where we've always had, well, it's actually downstream, it's more like at Doyle where it makes the turn, right? He's really looked at that area to try to better, and you'll see when Corey shows you that it's the improvements are working, and it's limited in terms of what we can do, but we're seeing no adverse impact as well. It's gonna help dry things. It won't dry it out completely, but it's certainly gonna help. So that, along with the mitigation on your property, should make a big difference. So no adverse impact. Some of you that went through this before, for every project that we implement, we have an independent engineer, meaning that he is not doing the engineering. So they're doing the actual engineering. He comes in and reviews that engineering, puts it through the flood modeling to determine if either upstream or downstream there are any impacts from whatever that measure is. It might be a channel, it might be a new box culvert, it might be a detention facility, whatever that is, that we're not creating those impacts, and their criteria, and he'll walk through those criteria that are used to determine is there an impact or not, a negative impact. And this is typically a very iterative process where they do some engineering, we run the modeling, have to tweak it here, tweak it there. This corridor hasn't been as problematic. Wupaki is very challenging. We've done a lot of iterations. But that's a very important process to ensure that we're not creating impacts upstream or downstream. So thank you, Corey.
Thanks, Lucinda. So you've seen the mapping, I'm sure, and that's what our base model is. And so then, as Lucinda said, I take what the engineers have created, and then I place that into the same models with only modifying the surface, and if there's changing the linings of whatever the linings are going to change for the channel. So that's what we're looking at. So here's Brandis. Here's going up, and you can see all the new scour that has taken place coming down through here. So with the analysis, we do it for the 1 inch rainfall in 45 minutes, the 2 inch, and the 3 inch as well. So for the 1 inch, that's about a 2 to 5 year recurrence interval, which is about a 50% chance of happening in any given year. And the 2 inch is about a 4% chance. And then the 3 inch storm is about a 1% chance of happening. So that's what we're going to be looking at for our NAI analysis. I'll just touch upon what the criteria is.
Flight in October. And so there's a light emitting laser device
It's light.
that they fly in a plane over the entire area, very precise measurements of the topography. So, and then they've entered that data into the new modeling. So this is all being based on post-flooding last summer. So it's much more accurate than the pre. So
Yeah, so any change that happened up in the
that's
upper
how
part of
we're
the
seeing all that additional erosion that happened, up on the forest and in the neighborhoods as well.
right, and so that's picked up in the existing condition, and then after our proposed conditions. So that's what we're comparing against, is what has taken place with the changes of channels in the upper part of the watershed and where the new flows might be coming, and the incisement and faster velocities coming off the mountain, sort of thing. So when we're looking at it, we don't want to just say that we can't make any changes, but whatever changes we make, we don't want it to negatively impact those downstream or upstream if we're ponding. So that's what we're looking at. It means we don't want to impact, so anything that would be caused by a project or a cumulative impact of projects must be mitigated. And so that's what we're going to be looking at. To do that, we're going to look at our water depths and our water velocities. For the 1 inch storm event, we don't want to see any increases more than 0.1 feet. And we don't want it more than a half a foot for the 2 inch storm event. And we don't want it more than a foot for the 3 inch storm event. And for all of these storm events, if the velocity is greater than 3 feet per second, because that can cause some erosion, we don't want it to be increasing by more than a foot per second, how fast, or 10% of the pre-project condition. So that's these are the results now, what we'll be looking at. So here's a change in water depth for the 1 inch. So you can see 0.1, the fan, we're widening it out, letting the flows expand out in the fan, hopefully drop off sediments as the velocity is slow. And then the same thing will be happening here. And then here's our terminal trench. So we're going to have an increase in depths, and then it's going to start reaching down the channel. And so in the channel, we're increasing the capacity. And so on the edges is where you're seeing the increase in depth, but we're not seeing any increases in depth greater than 0.1 feet outside of the channel itself. Here's our depths. Here's the Brandis corridor. So flows coming down the fan on the forest side, transitioning into the terminal trench and coming down the channel. It's fully contained for the 1 inch event. And then with the increased capacity. So 1,100 CFS, the design capacity that Rick was talking about, is just shy of the 2 inch event. So you'll see here's for the 2 inch event. Here's where it increases depth in the terminal trenches, increases in depths here. But again, it's all confined. The changes in depths are within the channel here. So here we're no longer looking at any depths greater than 0.1, but we're interested in depths that exceed a half a foot in the orange and yellow, and then red and anything greater than a foot. So 1,400 is still going to overtop the channel within a 2 inch event, but you're also being heavily impacted by flows coming from Peaceful through here as well. So hopefully improvements will be made on that watershed as well. And then here's for the 3-inch event. Again, it's all the changes that are greater than a foot, which is our criteria for the 3-inch event. It's all confined within the channel. And even though we're increasing the capacity, there's still there's going to be, the channel's still going to be overwhelmed within the 3-inch event. And that's shown by this November 22 condition on the left and our proposed conditions improvements on the right here. But so after going through the 1-inch, 2-inch, and 3-inch events, the NAI is met. There is shows a reduction in the flooding impacts. I would say that it might not be as much as we'd like, but up to about 1.75 inches is what we would expect the channel to be holding within the existing channel, and then it flows over that. You would anticipate that the channel would be overtopped, but at a less rate than before. So you would be decreasing your depths of what is overtopping the channel. And so it does demonstrate the technical and legal feasibility of the proposed mitigation also. And Lucinda will talk about.
Questions for Corey about the no adverse impact? Go ahead and add something, Chris.
So the modeling that you've done with the majority, almost the entire watershed that's on the forest, that modeling is based on the condition of the forest immediately after the pipeline fire. Is that correct?
That's our flows, yes. Yep. So the burn condition of it, so the terrain is not immediately after the fire. That is after the flows have gone through, incised, made new channels. But the soil condition is post fire right after the watershed, and that's why you see a 9 times increase of flows coming off the mountain compared to what the pre-fire condition was.
Most of the flooding occurred because the bridges that go across to the homes on the north side of Brandis all plugged up with big trees and big rocks that are like 3 feet in diameter. And every time one of them bridges, every single one, I got video, all 4 bridges were plugged from the very top all the way down to where the last bridge is. And the water was shooting up over them about 10 feet in the air. And I got video of all of that as I drove up Brandis as it was occurring. And so we have to, there's no way you could, that debris has got to flow underneath those bridges.
Right.
Because if it gets backed up, it just goes right, the water has nowhere to go. It's right over
Right.
Brandis and right down into the homes.
So I'll say a couple things. One is this model does assume clear water. Another, I think Rick can speak to increasing capacities, and then
That's
Alan
why
could-
the work on the forest.
and
That's
then that
exactly why.
Alan can speak to what they're doing on the forest, and to widen those fans, to widen it out. That'll decrease the velocity and allow some of this bigger items to drop out.
So they won't make it.
No, it actually reduces the sediment. That's the whole purpose. Yeah.
It's just wash out, there's no vegetation on the fans.
Well, there will be. It will regrow like it did last time. I mean, they grew beautifully. Yeah. We had major events out in the Brandis corridor before the 18. We had some pretty significant events through there, and no water even left the forest until the 2018 event. So it was very successful until we had the 1,000-year rainfall event. But it's still that 9 times increase is too much for those fans. We're also going to ask Tiffany to clear out as much as we can, like the dead and down material that's all in that area, try to get as much out of that area. And one of the things I'm hopeful that we can do as well, I've started the conversation with the Forest Service, is if we have money left when we get done with the measures, across all 9, is actually to go in and do the thinning again too. Go in and do thinning of the forest and clean out a lot of the dead and down. Because that's part of what happened in 2018 as well, right? It picked up all that dead and down it came, right? That gets stuck at the bridges. That's why the work on forest is so critical.
And the trees and debris coming down.
Yeah, it's,
At the bridges that were
Yeah.
going across there, the guardrails totally ripped them apart.
yeah, no, it's powerful force.
Oh my, yeah, it was crazy. Yeah.
I just want to say, I know that it's a different situation and different flood area, but the previous summer we had flooding in the museum flood scar area, and we had seven major floods with all kinds of debris that came down. And these fans this summer, after we were able to implement 3 of the 4 fans, cleared out that debris. We got sirens worried about flooding coming into town. We tried them, I believe once, maybe twice, but the water that came through that finally made it to the city of Flagstaff, by the time it got there, was a trickle. And like I said, this is a different situation. It's coming down from the mountain. There's more sediment, but those fans work. But the fans work is what I'm trying to say, and it can make a huge difference. We don't know to the level it'll make, but we know it will clean out those fans. And that's why it's so important that we get that work up there.
The important thing to remember is that when we completed this work in the 5 watersheds where we had agreement downstream, basically, other than the 1,000-year rainfall event in Brandis, water never left the forest. And we had very large events out there over that time frame. We've got that data. So this process works. It won't work in every event. We get these larger events, you're going to see water. There's no way, we can't mitigate every event, just like we said last time. But instead of doing 5-year, we're getting that up closer to 25 and going from 400 up to somewhere between 1,100 and 1,400 is where we're going to probably settle. So that's 3 to 4 times more water capacity. It's nothing's perfect. We're not going to be able to mitigate everything, but that's a substantial improvement. So
if they can keep the debris and sediment.
want to keep that on forest. That's the whole goal.
The ditch they put there on Brandis has a chance.
Yeah, exactly.
Yeah,
That's the whole purpose.
it'll be high because I've seen it without anything in it. And the water was right at the top going up onto Brandis, just water itself.
Yeah,
It flows fast.
yeah, it does.
Yeah.
It's moving.
You get in there, you're gonna be in a world of pain. You'll be hurt.
Yeah,
Yeah. It's the debris and the logs and stuff is the
Yeah, is
major
the
problem.
problem.
That's the
why the
problem.
on-forest work, exactly.
Yeah.
Okay.
Did you want to say something, Alan?
And Alan, anything you want to add?
Just going to reiterate everything that George said. Last summer whenever it rained, I was out there watching the forest and watching what was going on. And when we had issues was when the head cut went up into the fan and released all that sediment. It came down, filled the trench, and then came down through the channel. That all the other flows that came through there, where the terminal trench was empty and the fan was working, those worked really well, and we didn't have nearly as much issue with flooding or sedimentation in the channel, and not nearly as much cleanup. And so while this, as everybody says, this is not a perfect process, but this is the process that leaves the forest. We start the forest back to healing as fast as we can using the alluvial fan system to slow water down, keep it up there, keep the sediment, keep it up on the hill where it can grow stuff. And if we can keep those velocities on the fan down to below 2 feet per second, we can keep established grasses up there. Throughout, the pictures of the fan that you saw were from the summer. Outside of the head cut, we still have grasses that we grew during Schultz that are still doing their thing holding the soils on the fan. So the process can work. It does need some time, and that's why we do all this work to kind of accelerate it getting going. So
Yeah, I mean, that's the whole purpose of this. We can either wait 75 years for this to happen naturally, or we're advancing the natural process of recovery of those channels and those fans. And really, I always say we're putting it on steroids. We're advancing it really as quickly as we probably can, within the topography that's there. And that's why every corridor is different. Some topography is flatter naturally, and you have those fans, bigger fans naturally, and you can capture a lot more area and capture a lot more sediment. And then you have configurations of fans. For example, Wupaki Trails is much more narrow. It's steeper. If you've been back up in there, you've seen it. And it's much more challenging. So fortunately here, we did have ability to make some level of expansion, and that should really help. We're trying to maximize what we can up there. So, okay, great. Thank you, Corey. So in terms of next steps, as Rick mentioned, we're at 90% plans, and the goal is to wrap those up very quickly and get them into Tiffany's hands so they can get started on construction as quickly as possible. We've got a short construction season given both our financial dynamics that we've had to go through as well as the snow dynamics and everything. But again, if there's any team that can get it done, they'll get it done. Some of the work on forest can start a little bit sooner than some of the other work. We still do need a little bit more NEPA approval up there, right, Alan? That we expect to be coming fairly soon. They're marking the sites right now, and we should be able to start work up there very soon. Also, the NEPA approval for the channel, we did go through that process in 2012, 2013. We've had to do an update to that, but we expect that approval very soon as well. And then, of course, the final plans, NRCS, I don't know if they've gone over to NRCS yet, but they'll have to go for their final review. But they will address that very quickly. They're very responsive. We will also need an ADOT encroachment permit to expand that box at the highway because it does encroach further in. We got one before. We have to get an additional one now for that work at the highway. And we've selected the contractor. They have started work out there removing that articulated block because that's all going to come out, and we're going to replace it with shotcrete. So it's a much more smoother surface. It'll convey a lot more water than the articulated block was designed to do. So got a lot of constraints, with this process, the weather, hopefully they're right, and this is a dry spring, and we can, Tiffany can, and they'll work whatever hours they need to get it done. They're great. And we'll get the approvals quickly and all of that, but it's likely, they get to make the decision how they want to construct. Typically, we would want to construct from downstream upstream, because if they don't get it done before monsoon, it creates less risk. But they'll hit it hard and they'll get it done as much as they can. But there is no guarantee we will get it done by monsoon. They'll work into monsoon, and they'll work as long as they can until it gets so saturated they can't work. The good thing is that the plan that we have for this, they can execute that shotcrete pretty quickly. They've got a great sub that does that work with them, and it moves very quickly. We just did 2 channels last fall down at Paintbrush, and it really went very quickly. So we have a handful of properties that we're working with that we're working on some additional permanent mitigation on their property, and we will need to secure the cooperative agreements. They're aware of that, and we're working with them on those plans. So that's the process that we're underway. If you have general questions, we can all try to answer those. If you have specific questions about your property or a specific question on the plans, I think it's better that we break and you go and look at, go to the plans and say, hey, I'm concerned about this location or that location, and have the engineers answer your specific questions at the tables. It tends to be a lot more effective. But if you have any general questions, about the project. The goal is to get as much construction into construction, as many of those pieces as we can, as quickly as possible, and then try to get it done before monsoon, of course. And hopefully we'll have a normal monsoon this year. So another point I wanted to make back to the earlier conversation was that the first couple of rainfall events before we had the head cut up there got managed pretty well. You're right, Alan, it really was the head cut that really kind of was the game changer out there, unfortunately. Then most of you, I think, are signed. If you weren't, you're signed up now to get the routine emails that we're sending out with the updates. And what we've done now is we've created a specific Brandis email distribution list. And if you signed up tonight, then you'll go on that list, and then we'll be sending out routine construction updates during construction. But if you ever have any questions, I mean, you can call Public Works, but frankly, the fastest way to get any kind of answer, or if you have an issue or problem, if there's an issue with the construction that you have a concern about, it's better to email us. And Mr. Garrison will be driving around out there too. You can always flag him down. Civil Tech will also have their construction inspector out there. Raymond will be out there. He did the inspection in 2013 as well. He's excellent. He'll be monitoring all the construction. He can help answer questions as well if you have questions. But prefer you to use the email so they can stay focused on work. And we'll get to them and get answers if we need to get answers from the engineers or the contractor. So any general questions that anybody has about the process? Or we're moving really quickly. I know, it's a lot of information. We're moving really quickly, but we really want to try to get this done before monsoon. Sure.
Acquire or do repairs or something on? Are they in the Brandis area?
There are some in that area. There are a couple.
Okay.
And frankly, we're going to be meeting again next week, and we'll be looking at what came out of Corey's analysis to identify if there are some other locations that would benefit from what historically we called it individual lot mitigation. Now we're calling it integrated mitigation areas. But would they benefit? And Jonathan Archer, their property is one that will benefit from that. So if we see that there is a benefit beyond the short term to that, given the level of water that will still go through that area. Now, part of that, going back to that slide that showed that Peaceful is really having an impact to properties south of Brandis, right? There is still a big impact there. And so we'll be starting to work on the engineering relative to that later this spring, early summer. Hopefully this time that corridor we can get a consensus and we can move forward with mitigation in that corridor as well. It desperately needs it because it's affecting some of those houses further south of Brandis as well. Yes, all that area.
Yeah, because it comes down.
That's all Peaceful.
Yeah, it comes right down and comes right into the back of I have like a berm that was put there years ago. And the water that's coming down is just incredible. It looks like a raging river behind my house. And it hits the berm and it heads south and heads all the way down to Kevin's Way. And I know those poor people have got to be.
Yeah, no, it's horrible. And especially up at the top, right near the forest. There's a Grand Canyon going through.
Oh,
there
yeah.
right now. It's horrible.
That's Trina's house. Trina's got
it's
like
horrible.
a Grand Canyon going through her property.
So, but I mean, this is a great example of what's happening relative. This is just the 1 year, but even in the 2-inch, a lot of the water that's still going to come through that area is actually coming out of Peaceful. So it's.
So what kind of benefit are you referring to? Meaning that on Cinder Drive, I mean, the last flood, it just tore out the whole street. We are at the end of that, and we never got a visit from the county. Nobody came to do any type of damage assessment or anything. So
Well,
what benefit are
on
you?
private roads, all we can do is make them open and passable. We can't do any repairs or upgrades. That it's illegal. So private roads must be maintained by the private landowners that own those roads. So that's
Okay.
part of the issue.
So even something like simply providing dirt, gravel of some sort?
No,
just-
we
just
can't.
to-
No, we can't. Well, we've done a little bit in some places to make it open and passable, but we can't do it as an overall repair. That's just the legal consequences. It's considered a gift. So, but I would, if for those of you that if you're here and you're south of, I guess, Cinder, Cinder got hit more through the flow that comes through Jonathan's property. But if you're, let me see if I can get this to go on. There, if you're all through here, this is all peaceful. So I would really encourage you to, some of you are, if you're in here, talk to your neighbors. We need to get a consensus that people will move through. In last fall, we presented a concept of taking a channel basically down through here, very deep channel through here, and then back down to the detention facility. And we probably have 4 to 6 properties who said flat out they won't sign easements. So we're looking at developing an alternative, and we're going to present both, and then frankly, we're going to let the neighborhood decide what do they want to do, they want to move forward with. So I'm hopeful that we'll get something, but if we don't, then we'll probably come back and revisit, where do we go? What are the alternatives? So
Street up that
oh yeah,
wash comes through there and wipes that road out.
yeah,
Those poor
no,
people
it's,
can't get back there.
yeah, they've had to go across other people's private property to get to their
It's like
homes.
100 yards
Yeah.
wide when it comes through.
Yeah, because
the
it's
whole thing
all
gets just
private
washed out.
roads and, yeah.
And that all that water goes right to the back.
And I will say I was disappointed because when the SBA loans were made available, which basically are free money, that they had a process whereby they will work with you to form a road association. And then we talked a lot about that during all those meetings and got a lot of information out. Nobody took advantage of it, which would have been a great opportunity to upgrade some of the private roads. It wouldn't have reduced every impact, but it certainly would have helped. And but people didn't want to, that's your decision. So people didn't, that was a way to be able to actually get some funding toward that. So
Could I get information on that?
the period ended. It's done. Yeah, it went through 3rd week in November.
See, I wasn't even aware of it.
Yeah. Well, make sure. I mean, we had probably at least a half a dozen to a dozen emails about it. Plus, we had the meetings as well. So anyway, let's go ahead and break, unless somebody else has a general question, because I think some of your questions will get brought up in the specifics as well. So let's go ahead and break, and if you have questions, meet the engineers back. And again, thank you for coming tonight. Really appreciate your continuing to work with us. We're trying to have some positive impact out there, and I think you'll see it this summer. But we also know we can have bigger rainfall events as well than we did last year. So hang in there with us. Thank you. Thanks for coming.